Hello, ladies and gentlemen. Today we're going to be looking at a remote lab that we have. Now, this lab is going to be a little bit unusual, and that's because we're switching between our in-person learning and our remote learning in the middle of a cycle. And what that means is that your class, unfortunately, is missing the in-class portion of this lab. So I'm making this video to explain how to do this lab. It's designed to be a very straightforward lab that would work remote or in person. So I'm going to show you how to fill out this lab sheet. I'll go through the first two columns with you, and then you'll have to finish the rest up due later on. I'll probably put the due date on Google Classroom. It'll be due sometime the week after we get back from Thanksgiving break. So what this video is related to what this sheet is related to a video that you can see the link is at the top. I believe I also posted it to the Google Classroom. And if you go to that link, it's actually a video of me riding on the elevator from a little while ago. So as I step on an electronic scale, so I have an electronic scale here that's attached to the reader that I'm holding in my hands, you can see that I have a weight of about 900 newtons. And so that is going to be kind of our key fact that we're going to be paying attention to as we fill out this chart. So how this chart works is we have different parts of riding on an elevator. So at rest at the top, starting to descend, constantly descending, stopping, and so on. So when I'm at rest at the top, that's what we're reading in the scale right here. And hopefully you saw that I have the 900 newtons. Now it's important to note that a scale, a bathroom scale, does not read your weight. Instead, it actually is reading how much it's pushing up against you, which is your normal force. So the normal force on you is how much the scale is pushing against you, and that is what the scale is reading the entire time on the elevator. So I'm riding the elevator. You're going to notice the scale change over time as I'm riding the elevator. My weight is not changing. I'm not working out on that elevator. I'm not eating a lot on that elevator. My weight is going to stay the same the entire way down. However, my normal force is going to change. The elevator is going to hold me up, sometimes more, sometimes less than 900, which will cause me to, go up and down. So that's what we're going to be looking at here. So the normal force is whatever is read on the scale itself. So whatever the scale reads is the normal force. Then my net force is 0. My velocity trend, well, I'm not moving at this point, so I could write 0, or I can write like non-applicable, either or. My acceleration, again, is 0. I'm not accelerating. Now, free body diagram. So you'll notice that I gave 2 sheets in Google Classroom. One is a Google Doc, and one is a PDF. The PDF is for you to open in Kami if you want. You can pick which one you want to work on. From the people who did it in school, it turns out the PDF is probably the way to go of Kami because you're going to need to draw these free body diagrams. And frankly, it's a pain to do that in Google Docs. It's very easy to do it in Kami. So you're probably going to be filling this out in Kami. My free body diagram, every single one of these, I'm only going to have 2 forces. I'm going to have weight and the normal force. And in this case, my weight is the same as my normal force. I don't know why that's moving like that. That's pretty weird. So they're the same, equal, and opposite to each other. Let me just flip this. Rotate. Flip it like that. Attach them. I don't know why they're both moving at the same time. But the key is that they are the same, and they are both in opposite directions. We have gravity going down. We have the normal force going up, and these are the same as each other. That's pretty straightforward. So this is what the first row will look like. Now let's look at the second row when I'm starting to descend. So you'll notice that I'm going to hit the, after I find the button, hit the first floor, which means the door is going to close, and going to start to descend. And what you'll see is the number drops. So it raises a little bit because I'm leaning back on it, but after you hit it, you'll notice it will drop to a much lower value. So after I stand back up, you notice it goes down. And what you want to look for during this lab is look for the most extreme change. You're either going to have values that are higher or you're going to have values that are lower, but they're going to change a lot. You want to pick the most extreme difference. So in this case, 874 is when we have the biggest change. So if we look over here, ignore that higher, it gets lower, jumps around a bit, but 874 was the biggest change. So that is my normal force, 874. My weight, again, I did not work out, I did not diet, so it stays the same at 900. My net force, because these are in opposite directions, we're just simply going to, sorry, I'm just getting ready to draw the next one. I don't know why this is acting so weird. That's so peculiar. Anyways, so I just subtract them because they're going in opposite directions. And the normal force should be smaller. So we have a bigger gravity, a smaller normal force, because normal force doesn't hold me up. That's what's causing the elevator to accelerate me down. My velocity, trend, and direction, I am increasing speed, and I'm going down. Hopefully that makes sense. We're going to see me increase speed, decrease speed, remain the same speed. So you should have whether I'm increasing, decreasing, remaining the same, and then you should have the direction as up, down, or non-applicable. I'm not moving if I'm standing at rest. Now, to calculate my acceleration, we're going to be using the formula A is equal to F net over M in order to calculate the formula. So my F net is our 26. M is actually something that you're going to need to calculate at the start. And how you're going to calculate is the formula G is equal to Fg over M. Fg being my weight is 900. M is what you're looking for, and G is 9.81. If you do the calculation correct, you should get something around 90 for my mass. So you should get a kilograms around 90. So you need to calculate the acceleration, and it's just going to be 26 divided by that number you get for my mass, which again is going to be around 90. You should get an acceleration that's pretty small. Elevators do not accelerate you very quickly. I expect something significantly less than 1, something like 0.1, 0.2, around that area. As you watch the video, you should pay attention. You'll notice that it will jump a little bit. You can see it's like 903, and then sometimes it gets less as I'm going down the elevator. If it's around 900, just say 900. It's going to jump around plus or minus 3 or 4, just because as I shift my weight, because the elevator is vibrating a little bit, you're going to notice small changes in weight. Don't bother with those. Only pay attention to, you can see I'm about to hit 1, I'm stopping, and then we get an extreme change. I saw 940. So only if you see a big change is what matters. Any really small change around 1 or 2, just say it's 900, make it easier for yourself. So your goal is to fill out the rest of these and then to answer the questions. If you have any questions on this, please let me know. We're going to be starting a new lab next time. I'm not going to say this is due next time simply because you won't have the opportunity to see me, but it's going to be due shortly after. So maybe you'll have the opportunity to ask me questions. Also, the other lab is due as well, the one with the accelerating on the cart. I had 2 major questions with that when it came to things we worked with in person. So now we're going back to the previous lab. Question 5, where you had to draw the mathematical model, and question 6, where you had to find the mass of the person. For question 5, the mathematical model, I'm simply looking for the formula that relates acceleration, force, and mass. So you just have to pick that formula. That's all you need for it. Really simple. For question 6, you have to use that formula to calculate the mass of each of the volunteers. The forces that you're going to get are the forces on the front. The 5 pounds and 10 pounds, convert those into newtons. Feel free to use Google for that. I believe it's something like 22, 44, something like that, but just use Google to make sure. Those are going to be your forces. Your accelerations are the slopes of the graph that we made. So we made a graph, we got 4 lines from it, 4 slopes. So we have 4 different accelerations. You're going to use those accelerations with those forces to calculate the mass. And again, if you have any questions, feel free to email me. We'll probably have a little bit of time to talk about it next time we have a lab. That's all we have for today. Oh, I'm going to be putting up a place on Google Classroom to submit the previous labs. I just need a picture of it, I think is going to be the easiest way. And then you're going to submit the previous lab stuff on Google Classroom. Okay, I think that's all I have for today. I hope you all have a good day, and I shall see you remotely in not too much time. Goodbye.